Okay. Now, normally everyone should basically validate. Before we start actually the presentation, I'm stalling a bit. So Rob, can you maybe tell us where to find you soon? Do you have any new conferences that you're going to be at? Any new talk you're preparing? Anything?
Yeah, I did a brand new talk on PowerShell yesterday. That was a lot of fun. I'm working on a brand new talk for microservices. I'll get to do that in a few weeks. I'll be at a conference in India in April. That will be really fun. And then I'm back in Europe in person in May. I'll be at SDD London and Techorama and also IPC Berlin.
You're not going to NDC Oslo this year?
Am I going to where?
NDC Oslo in May?
NDC Oslo? I'm not. Yeah. I actually had a conflict between NDC Oslo and IPC Berlin, so I wasn't able to go.
Okay. Okay.
Yeah, I keep trying to get to Oslo, and last year I forget what conference I was at, but I also had a conflict, and I debated, do I fly in for the day and do my talk in Oslo and then fly out? And I really want to do the whole NDC Oslo experience, so I had to say no to that talk, and that was really unfortunate.
Yeah, I imagine. Yeah. And you mentioned the talk about PowerShell. Is it the one on automation with PowerShell?
Yeah.
Yeah.
It's a getting started with PowerShell talk. It's really fun.
Okay. So
I did a similar talk at another group getting started automating with Bash. And so it was fun building those two talks. I was presuming as I started building them that they would be pretty much the same. But as I got into it, they started growing apart. PowerShell has .NET built in, which is incredibly interesting. And Bash being kind of the standard installed everywhere, you're probably using Bash in the middle of Docker files as well. And so it's interesting. They both have their perfect use cases, and they're not the same use cases. That really surprised me.
Okay, everyone, it's almost 35, so I think we can start. So just before letting the hand to Rob, if you have any questions, feel free to ask in the chat. Today I'm with Tinael right here, right there, blurred Tinael, and I have Arthur just in front of me right there. We'll be doing our best to moderate and try to basically gather your questions for the Q&A at the end of the session. So don't be shy, ask questions. Cool. Rob, as we say here, usually the floor is yours.
Excellent. I'm really excited that I get to join you here in Luxembourg. I've been looking forward to this for a while. We get to talk about scaling the testing pyramid in TypeScript. How do we test things in our website? How do we test components, APIs? How do we test small functions? How do we test in particular browsers? That's really what we'll unpack today, and we'll take a look at different tests in all kinds of places. Here's the part where I tell you, I am definitely going to post the slides on my site tonight. I've been chasing similar speakers where they say that and they never post them, which is why let's head to robrich.org, robrich.org, and we'll click on presentations. And here's scaling the testing pyramid in TypeScript. The slides that we'll use and the code up on GitHub, they are online right now. Achievements unlocked. Woo! So I'm really excited. The slides are already online. While we're here on robrich.org, let's click on About Me. Thanks for the introduction. Here's some of the things that I've done recently. I'm a developer advocate. Microsoft and Docker have also given me some awards, and friend of Redgate as well. I actually just learned today I got renewed for another year. That's exciting. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Luxembourg or wherever you're connecting from, find me on Twitter or Mastodon. Here's my links up here at the top. And let's get a give camp in your neighborhood too. Some of the other things that I've done, I run a user group both in Provo, Utah and in Phoenix, Arizona. And I got to work on the Gulp project in version 2 and version 3. So I got to help shape the JavaScript build system there. So let's dig into scaling the testing pyramid. We talked about this guy. Testing. Why do we test? What are we looking to accomplish? Is this just one of the things that the project manager says, no, you need to do this? Well, why do we test? Probably the reason that we usually reach for is to validate behaviors and boundaries, and we definitely want to do that. But we also test to document a code's intent. Tests, if they're written simply and legibly, become great documentation for us of how the system works. And in particular, one of the primary reasons that we test is about risk mitigation. If it's cheaper, easier, simpler for us to write a test to validate that this condition can never happen than to try and fix a production outage, then our tests are definitely worthwhile. Anything that we can do to mitigate risk is wonderful. Now, if our system isn't that system critical, if its uptime is not all of that important, then maybe writing tests is not valuable because we're not mitigating enough risk. So let's dig into types of tests. Well, we might have end-to-end tests, we might have integration tests, we might have unit tests, we might have other types of tests, but as we kind of categorize these integration tests, end-to-end tests, user experience journey tests, and then small functionality tests with unit tests, we can kind of compare these and see, well, unit tests tend to be a lot faster, so we'll probably have a lot more of those. By comparison, end-to-end tests are a lot slower. So maybe we're not testing all of the edge cases with end-to-end tests, rather we're going to do that with unit tests. These slower tests can help us kind of smoke test the system, but we're probably not being really exhaustive in our integration tests. So that kind of helps us gauge, should we build more or less tests like this? What are the critical pieces where this type of test can help us? And we end up with the testing pyramid, where we'll have a few end-to-end tests. We might have more integration tests. Integration tests will test from here down, but may not be the user experience. So maybe we're hitting the API and all of the dependent services and validating that all of that system works correctly. Or maybe we're using the front end's back end. So, the API calls that the front end will make and validate that everything works there. But maybe we're not clicking through the user journey in integration tests. Then we'll have a whole lot of unit tests proving our functions work the way we expect. Well, that's kind of the way that we want to do it, but probably we end up with a big ball of mud like this. Do your tests look like this, where we have a whole bunch of manual tests? We have a whole bunch of people clicking buttons every time. We might have some end-to-end tests, and then we have a really small amount of unit tests. Yeah, we put our pyramid upside down, and it gets it done, but it's probably a lot more labor than we're looking for. Manual tests definitely have their place. Let's do exploratory testing. Maybe let's do a smoke test once we deploy. But the more that we can automate that, the more that the manual test can be about discovering unusual circumstances and less about proving the behaviors that we have. Will we talk about tests in TypeScript backends as well? Yes, we will. We'll actually have some examples with backend TypeScript tests. Great question. Thanks for that. So here's the testing pyramid that we want to aim for. A few end-to-end tests, a whole lot of unit tests, and kind of balancing out to be able to validate both our software works correctly, but also have a performant test suite so that we're not waiting a whole long time for our test to finish. So taking that methodology of how we want to test, and let's apply it here to talking about testing pyramid. Have you heard about the testing trophy? I have. The testing trophy is interesting, a cool way to establish it, where we have a whole lot of things down at the bottom, and then we kind of bloom up into the trophy. It's a cool metaphor. I like it. So we're building tests in a browser. This testing methodology could apply equally to browser-based software or installed software, software on a mobile device or a tablet, perhaps on a watch or another device. What's different when we test things in a browser? Well, as we look at these tests, we'll probably have those same suite of tests, unit tests, integration tests, end-to-end tests, but we'll also test other things as well. We want to test, well, components. So in a web context, we'll need to mount our components in a spot and be able to poke at them that way. We probably also want to test our backend API. And the interesting thing here is maybe it's a REST API or GraphQL API, but we don't need a browser for this. We can just hit our endpoint and validate that we get the result statuses and content that we want. And we might want to mock dependencies. Now, mocking dependencies is really helpful because we can replace an expensive dependency with one that we can completely control. So maybe we don't want to run tests about charging credit cards because we don't want to pay the credit card bill. So we'll mock out that credit card service. Or maybe we have an expensive backend that takes a while to compute this query, and we'll replace it with a much more predictable result so that we can test things like, do we correctly handle error conditions? Do we correctly validate that our system behaves as expected? That's really cool to be able to mock out those dependencies so that we can focus on this particular thing. Now, we'll probably do that in unit tests. We may do that in integration tests, probably not. But we definitely don't want to mock things out in end-to-end tests because we really want to be able to flex the entire system. So what software might we use in different places? This talk actually grew out of this slide. This slide was embedded in a different talk, and they said, hey, can you show me examples of everything? Can you show me examples of each thing in various places? And here's the talk. We're going to talk about tests in each of these scenarios. Now, if I'm doing unit tests, if I'm just testing specific functions, I might use Mocha with try, or I might use Jest. I could also use Jasmine. If I want to test these unit tests in a particular browser, I might use Karma, or actually saw a demo of using Cypress to mount components, and that's really intriguing. If I want to do component unit tests, then I'll probably use test utils. And there's an addition of test utils that works in each SPA framework. So in this case, we'll do some Vue tests, and so we'll see test utils working in Vue. As you grab these slides from rawrich.org, you can click on each of the blue links to learn more about that particular framework. As I'm testing APIs, maybe I'm just using Axios in the same way that I use Axios in my front-end application. And so now I'm just writing API calls to be able to hit my endpoint. Or if I have a GraphQL endpoint, maybe I'm using Apollo to be able to hit that API endpoint. For end-to-end tests, we might use Selenium, Cypress, Test Cafe, or Playwright, or others. We're going to look at Cypress today, but if you've found a framework that you like, then that's definitely the appropriate framework for you. Now, the cool part is because we want to test lots of different things, we'll probably use many of these tools. So the natural question here is, well, which is the best tool? Well, it depends on what you're trying to test. For end-to-end tests, we'll pick a tool from down here. For API tests, we'll pick a tool from here. For component tests, we might choose these, or we might choose Cypress. For unit tests, we can choose this framework, or maybe we use TAP or Tape. And we'll get to see how each of these play with TypeScript as well, which is really fun. Any questions so far on the types of tests that we might write or the tools that we might use?
I don't see anything in the chat yet.
Excellent. So one note on Mocha with Chai or Jest or Jasmine, which one should you choose here? They are pretty much the same. With Jest or Jasmine, they presume that expect is already in scope, so you don't have to define it. And here you say .to_be. In Chai, you say expect .to_equal. That's the only difference between these libraries. There's a few more differences the deeper we get into it, but for the most part, there is no substantive difference here. So if you really like Mocha and Chai, then that's definitely the right tool. If you like Jest or Jasmine, then you can definitely be productive with that as well. Jest is the most modern of them, so that's the one that we'll use today, but you can definitely find success in all of them. And it's really not that different. .2.equal versus .2b, that's not a substantive difference here. We're also going to use TypeScript. Now, TypeScript is a superset of JavaScript, so all valid JavaScript is also valid TypeScript. But TypeScript also helps us define our types and helps us validate our types. And so in our tests, as we start talking about mocks, we're also going to need to satisfy that interface within our mocks. So it'll be fun to be able to look at not only the JavaScripty bits, but also the TypeScript bits. Mocking. We talked about mocking, how it's really fun to be able to swap out an expensive resource with a resource that we can control more easily. At that point, we could say, well, what if the API returns a 500 or a 404? And we can take control of that API to be able to make it behave in that way. We could also take control over other dependencies. And what's interesting in NPM is that we import things. So the majority of our dependencies are singletons. And so it'll be interesting as we start talking about mocking, how do we swap out those singletons? Now, as we peel the onion with mocks, there are mocks, stubs, and fakes. And the difference between them is definitely interesting. We'll ignore all of that for now and just kind of talk about mocks, meaning all of them. But yes, when we're around a pint, let's definitely peel the onion and look at the difference between mocks, stubs, and fakes. So here's our list of tools. And the cool part about this talk is we'll get to see an example of each type of test here. And so as you grab these slides from rawrich.org, you can dig in more with the code here, or we've also got the code up on GitHub. So here's that repository right here, where we'll get to look at all of the content in our system. Now, this is a really fun app. This is an app that doesn't have a whole lot of complexity in its business logic, but it is complex enough that we can play with it. So it's a tic-tac-toe board. And we can see that you can't click on an existing square, but you can click on a new square. And once we've got a tic-tac-toe, then we win, and we can't even click on the blank squares. We've got a leaderboard that keeps track of how many times each side has won, and we can click new game or clear scores to be able to set up a different way. So that helps us to be able to get a feel for this game. Now, this game is broken into two sides. We've got an API and an app. The API keeps track of the score, and the app is going to do most of the logic around the game. So let's dig in and let's take a look at testing. So I'm going to start out first, before we dig into that application, let's do this really simple app. There's a lot of people who talk about time to first it. So let's build a test. Hello, world. I'll do a TypeScript file. I've already got my tsconfig, and I've got Jest set up. So it should pass. Let's create the test that we want to build here. That's our second parameter into the it function. And we'll say assert true. And we'll pull in assert. And we have a test. Now in this test, it's not doing a whole lot, but time to first it, that was pretty simple. npm test, and we can get our test off the ground. Excellent. Now the hardest part about getting started with testing is to get to the first test. So we just did that really quickly, almost automatically. Very nice. So we've got a passing test. That's wonderful. Now, this test isn't doing very much. So instead of assert, the built-in testing library, let's flip this over to Jest. Now, Jest already has it imported. I've already imported Jest from my npm modules. And I also imported the types for Jest because we're here in TypeScript. I'll also import, I'll also then say arrange act assert. And this arrange act assert pattern is really good to be able to set up the condition and then test it and then validate it as expected. So in my act, I'm going to say const expected equals 4. And then in my assert, I'm going to say expect expected to be actual. Nope, to be expected. I got those backwards. Expect actual to be expected. So here's my actual, and I'll need to set up my const expected to be 4, and now we've got that test. We could also then wrap this in a describe block that will identify the type, the group of tests that we've got. And so now we have a fully formed test, still a hello world test, but now we've flipped over from using assert to using jest. And so let's run our tests again, and we can see that we still have one passing test. Cool. Now let's test something a little bit more. Now I have this add function here, and this add function just says, let me take in 2 numbers, return a number. I'll make those work. So let's test that. I'm going to create another new test, new file, add.ts. I could even say test-add if I wanted to. Describe. This is the add function. And so what are the tests that I have in this group? Well, there's that. Let me import add. And so now let's set up some tests. Well, it should add 2 plus 2. I'll create that test. And then because I don't want to accidentally fail this test, let's throw new error, not written. I like to do that because it's really easy to set up a bunch of blank tests and then run the test runner and presume that they're all green. So it should add 2 plus 2. We might also want to look at this and say, well, it could add A plus B. Now, 2 plus 2 is interesting because if the add function actually multiplied, we would still get the same answer. So I'm not going to add 2 plus 2. I'm going to add 2 plus 3. If I multiplied 2 plus 3 and I added 2 plus 3, I would get a different answer. Okay, let's implement this. Arrange, act, assert. So here in my act, const actual equals add x and y. And now let's assert, let's say actual or expect actual to be expected. Cool. So now that we've built our behavior and our validation, we now know what we need to set up to make that happen. To some degree, we're TDDing our TDD tests. Const x equals 2, const y equals 3, and const expected equals 5. We can do a similar thing here then with our adding strings test. Let's say x is A and y is B. So we should expect A, B as our result. Now, Typescript is going to be mad because these aren't numbers, they're strings. But let's run our test and validate that all of those tests pass. Excellent. We now have a bunch of tests and all of them are green. Well, except for our TypeScript error. Oh, I did import it incorrectly. Import add from add. There we go.
I'm using this time to interrupt just a little bit because I read the question from the chat. And so actually, apparently those tests are a little bit slow given the content that they have. Do you know why it's happening?
That's a great question. Why are my tests taking 4 seconds to run? Because my machine is overloaded. I'm also running Docker. I'm running 2 Node apps. I'm running Zoom. And so Yeah, I would not expect these to run in 4 seconds. I would expect them to run nearly instantly if I wasn't doing all this other stuff on my machine. Great question.
That's fair. Thanks for clarifying.
So we did get one failed test because it's a string, not a number. So yeah, this test probably should test, I don't know, -1 plus -3. That might be a better test. Let's test if we're adding negative things correctly. And now that test would go green. Cool. So we were able to live code this unit test. Let's now apply it more towards the other system that we're looking at. Well, here's our application. Our front end application is this view app. So we have this app that then creates the 2 player tiles. Those are these pieces up here, player X and player O. Then we have our 9 board squares. And then we have the new game button and the leaderboard button, component. The interesting thing is that we're actually injecting the score list into that leaderboard component. And we've done this intentionally so that the leaderboard component is really only rendering, it's not computing. That way, when we go to test our leaderboard component, we don't need to mock out API requests. We can only focus on the rendering pieces of this leaderboard. That works out well. Rather than moving to Utah, I would consider buying a new machine. I agree. Is refactor as easy as C# for test builders and TypeScript while having project code base growing in size? It is slightly different than C#, but it is kind of in a similar methodology. TypeScript is only a design time type piece. And so at runtime, it's still running JavaScript. And so you can kind of cheat and do some interesting dynamic typing things that you can't do in C#. But yes, refactoring in TypeScript is really helpful because it will say, hey, I don't think you called that right. I agree, it's brilliant. So we've got this leaderboard component that is only rendering. And now how do we compute the scores? Well, here's our game loop right here. We've defined all of our squares. And here's our game loop where we go check to see if we win. And if we won, then we'll do a game over and update the score. Otherwise, we will go check to see if we got a stalemate. And if so, then we'll do that. And otherwise, we'll loop back over and let the next person play. So here's the next turn where we just flip from X to O and back. And so that next turn will work as well. So let's hit new game. We'll set our turn. We'll set our game over to false, and we'll start looping in through it. So let's start with checking the win. Oh, actually, so when we go call our APIs, that's going to reach into this data service. So we'll go reach from here that will then call our backend to go get the scores or update the scores, identifying which player won. So looking at our backend system, let's flip from front end to API. Here's our API, and we have various routes. So here's our index route that basically just says, you need to be running the front end. And then our score API, which will go retrieve all of the scores, or our post API that will go update all of our scores. Now that calls into this get scores method. Get scores comes from data. And so here we've got a get scores that will go get the data out of Redis. Now, in this case, I'm passing in a Redis client. Maybe it makes more sense to just have a singleton in my application. But I think it's kind of fun because testing this method will get kind of hairy. We need to go get our Redis and be able to pass it in, but that's not really the focus of our test. We also have a default score in case Redis is blank. That default score just says, hey, I'd like to return some defaults. So here on our backend, we have those methods that will interface with Redis, and that's pretty interesting. We'll want to build unit tests and integration tests here. So let's first start on our front end. We want to check if we can win. So here's our check win method. Here's all of our win conditions. If you have scores 0, 1, and 2, or if you have cell 0, 1, and 2, 1, 2, 3, then that's a win. And here's all the conditions. So when we check win, we'll get an array of squares, and we'll say, is that square condition a win? And if so, we'll return the squares that won. And so let's unit test this. Now, the cool part here is we have no dependencies. We just have a function. So let's go test it. Right here, tests, unit tests, check win. There we go. So here in our check win, I'm going to arrange the squares the way I expect it to be. Now, yes, this is one array, so I could choose to format my array this way, but I really like that this nicely documents the business logic here. This test is really clear. I've set up the board the way I expect it. I've set up how I think this will win, and now I'm going to go call my test. Now, in this case, I noticed that the act and assert were pretty much the same in all of these tests. So I just moved that arrange and act and assert here. Here's that run test. Pass in a list of players. I'm going to turn that list of players into a list of squares. I will pass that into my check win function, and I will validate that what I got was what I expected. Excellent. So here's X winning. Here's O winning. This is a vertical one. Here's one where I expect there to be no winner. It's stalemate. And here's a blank board where I expect to also not have a winner. So here's my array of winners, and nope, I don't have a winner at all. So there's a unit test. That's really cool. We still have our arrange, act, assert, but to avoid a little bit of redundancy, we moved that into this run test method that allowed us to make these tests really legible. You can now look through here and say, oh, yeah, there's a stalemate board. Here's an O winning board. Here's an X winning board. These are very, very simple, elegant tests. So we've done some unit tests. Now let's upgrade to looking at some component tests. Now we have our leaderboard component. We know that that's just rendering. And so we don't need to worry about how we might compute various things. We're only injecting those as props, my score list. So let's create a test for this fixture. Here's our leaderboard test. We're going to import that leaderboard component. We'll also import the test utils for, in this case, view. So let's set up our solution. In this case, we want to render the leaderboard as blank when we have a blank score. So let's mount our component and pass in our props. And now I want to take a look at how this will render. Well, here in my leaderboard, if I don't have any square content, then none of that will render. And so all I'll get rendered is this clear score function, this clear score text rather. So let's take a look at that leaderboard, and let's go grab the text, and let's see if it just says leaderboard and clear scores. Leaderboard and clear scores. We're not rendering anybody that doesn't have any scores. Excellent. So we grabbed all of the text out of that mounted component, and we're able to validate its results. Next, let's pass in a bunch of scores. So X has 3, O has 2, the tie has 1. We're rendering these as different scores so that we can then go check to see if it rendered correctly. So let's mount it. Let's pass in that score list. Let's go grab our text. And I expect it to say tie is 1. Now that's cool. I said expect to contain rather than expect to equal, as I did previously, because there's a lot of other text going on. I could also grab the HTML and validate the HTML DOM works as expected, but that might be a little bit intense. I'm really only after, did it render this score correctly? So that's the piece that I'm going to render in this case. So that's great. We took a look at a component test where we were able to mount our component into this fake DOM environment and be able to render it in an interesting way. So that's our API, that's our app tests, and we'll dig into more end-to-end tests as we get going. But we have a whole bunch of unit tests. We have a whole bunch of component tests. And next, let's go to the back end and take a look at the tests that we might do on the back end. So here on the back end, we have our get all here. Now here in the get all, what if we wanted to unit test this function? Well, we need a request. It needs to have an app property that gets something, that is of type Redis client that we pass in here. But I want to test this and I want to say, well, if Redis is blank, do we get the default scores? So let's take a look at that test. Now here's a unit test for score.get. Now in this case, we want to be able to do that, but we don't really care what the request is. We just need to validate that the request produces the right results. So I'm going to set up get scores with these Redis scores. That's how I want to mock my Redis instance. That is what will return when I come here and I say what comes out of get scores. So let's that's what I'm doing here. Let's go set up that mock. Now I have this Redis scores, and I want to then import mock.mock function, that score data. On that score data object, I want to mock get scores. And instead of returning what get scores usually would return, I want it to return this one. And I'll cast it as a sign-on stub in this case, because this library actually sits on top of sign-on. But the cool thing about import mock, let's come here to the top. Import mock came from TS mock imports, and it allows me to mock out methods in classes that I import. So notice that I'm pulling in the score data, and I'm importing star as score data, rather than just importing the method that I want, because now I would only mock my instance. Really what I want to do is I want to mock the get scores method inside that score data object, swap it out so that when my code under test reaches into it, it will actually get this fake one instead. So we've done that. We've imported we've set up our Redis scores. Now let's set up the score defaults. So similar thing, I want to mock the function score default. Now score default actually includes a default, export default. So in this case, when I'm mocking it, I want to specifically say mock the default property, and I'll return what I want. Now I chose to put these two pieces in little methods. That made my test a little bit more intelligible here. I didn't have to go build all of that stuff right here and make my test really verbose. Instead, I could just say, hey, go set up those mocks and go do the thing. Now I want to get this thing. I'm just importing get from my route. And I need to pass in not the scores, not the Redis details. I need to pass in a request and a response. That's the content that we have here in our method, the request and the response. Now they're of type request and response respectively, coming from Express. So here in our test, let's create fake request and responses. Again, I'm going to create some little method out here that allows me to focus on the logic of my test here, not on the implementation of how I might choose to mock those out. So what do I need to mock in this test? Well, I've got this method that takes in a request and a response. So I need my request to have an app property that has a get method that returns something. Now, the interesting thing is I only need to pass that something over here to get scores. I don't really need to use it. So it doesn't have to be an actual Redis. I just need some object that get scores believes is a Redis client. Then I need a response that has a JSON method that I can return those scores to. So a request that has an app with a get method and a response that has a JSON method. So let's come back to our test and take a look at how we might mock those. So I moved these into this little method, and this little method, let's go create a mock of type Redis client. Create mock came from the TS auto mock library, and that's great for being able to mock parameters and other content. So here in this create mock, it's of type request, and I'm going to pass in this partial of request that is just the implementation that I want for my request. So in this case, I have an app that has a get method that happens to take in something, and I don't care what it takes in, but it returns this Redis mock. I created that with create mock, and I said, well, in this case, it has no implementation. I don't really care what it does. I just care that I pass it on, and it is of type Redis client. So create mock was able to build me one of those, and I'll just set that here to return at when you call the get method. I'm also going to create a mock response that has a JSON method, and it's going to get past that body. Now I want to be able to set that body somewhere so that I can go validate it. So I'll just call this onJSONBody method that I just have as some method that returns void but takes in a score or undefined. So now I can call this, have this callback that will get the value that I've set to this.json. And I'm returning this as a response in case I do something like here in my route, I could say .json.setStatus. And if I were to chain it in that way, I would still want it to return this in the correct way. Cool. So back in our test, we've now set up our other mock here. And we're now back here in our test where we've got our fake request and response. We passed in this lambda to be able to grab the scores. So we'll just set it off in this scores property that we have here. So it'll run, it'll go pass in the things, and we expect the scores that we got out of that response to be our default. Here in our method, we said we've got nothing from Redis, so we want to get our default score. So in our test, we've got nothing from Redis, and so we want it to be our default here. Our Redis is blank. Cool. So this test was able to mock out lots of details in Express and lots of details in Redis that weren't important to the content of our test. We just wanted to validate if Redis was blank, we get our default. Well, what if Redis isn't blank? We're using our same mechanisms to be able to set up all of our mocks, but now we have content in Redis and our default. And so now when we run this, we expect scores coming out of our response.json method to be the Redis scores. So we're now able to run unit tests around our API. Now, the cool part about this unit test is that we just need to spin up a bunch of stuff. Now, we have very specifically set restore on our mocks because we want to be able to put our methods back after our tests run. It would be easy for us to leave our mocks in place, and then if we had an integration test, well, it kind of is broken now. We've swapped it out with our mocks. Mocking our own code seems quite easy, but what about code on which we don't have our hands on, like packages? Exactly. This one came from the Express, the request and response, and so we were able to mock those out with TS automock. And TS mock imports is great for being able to mock out our dependencies. Great question. Can we simply...
I'm jumping in to give you context about the other questions. So the first one we had was, can we also mock object as easily? And this happened when you were actually mocking get scores, if I remember well.
Mocking get scores. Yes. This is mocking a dependency, an npm import, which is why I use this function. But yes, if I wanted to just swap in a mock, I could just say, here's my score. Use that instead.
And there was another one, can't we simply substitute interfaces like in C#? And this was when you were mocking the Redis client.
Yes, mocking the Redis client. Can't we just swap based on interfaces? Kind of. In TypeScript, the types only exist at design time. So during runtime, if we try and reflect on that object, it no longer has its type information. So we can't say, just implement the thing that showed up, because the thing that showed up is, well, undefined. And so we actually have to mock things based on design time interfaces. And that's exactly what we've done is, here's Redis client, and that is our interface of how Redis works. And so we're just going to create some fake Redis client that does whatever we need it to do. In this case, we don't need to do anything. We just need to be able to pass it between here and there. We need to get something from here that is of type Redis client, well, matching the Redis client interface, and set it in place in this method, just so that the getScores method has what it wants. But in this case, we chose to mock out the getScores method as well. And so, yeah, it's just going to go, okay, I got a thing. Sure. Great question about interfaces in C#. In the second test, isn't it weird to mock out the defaults if we know that we'll get the data from Redis? Good call. We could leave this as undefined and say, well, we got our data from Redis, and so we know if we get undefined, bad things happen. Now I chose to actually implement this and go validate that I got the correct one because, well, in my business logic, the business logic assumes that my default score is always not null. Now, this is not score or undefined. It's actually a score object. And that's why I chose to actually implement a score. But that's a great question. So we have now unit tests around our API, and we could also write integration tests against our API. So let's take a look at an integration test for our API. Am I in the right? Yeah, I am. So here in my integration test, now instead of looking at a particular route, I want to run my entire app. So let me call getScores. Here's our getScores method. Let's just use request to be able to call API score. And I expect to get a response. I'll grab the body, assume it's a score or undefined, and then expect that score to be truthy. Now in this integration test, I don't know what the values are of X and Y and tie, so I can't validate that I got that, but I do want to validate that I did get a result, that I typed it correctly. So I'll do a similar thing for post scores. In this case, I'm going to take in a player. So let's go do a request to my app, send the player, and I'll get back the current scores, including that update, and I'll validate that I got that score as well. Now, the one thing that I did is I rigged up these two not as separate tests, but rather as methods in this test. So I'll go validate that get works as correctly, grabbing the scores. Go validate that post works correctly if I update the X player to be the winner in this particular game, get those scores. And now I'm going to go validate that the X player changed and that the O and the tie did not. Now that was a cool integration test because I was able to look at all of these pieces, not only validate that my get and my post work, but that it increments the score in the way that I expect. Now, these integration tests are actually going against real Redis. So as I spin up my app, I've turned my app here into a function rather than just a singleton. And that means that it'll go spin up Express, go spin up Redis, and then return my app. Now, it would be really easy for us in our test to accidentally leave Redis open. And so you might see, as you say npm run, it runs all of the tests, and all of the tests succeed, and then it just hangs. Why is it hanging? Because I left my database open. And because I left my database open, now it doesn't know that all of the promises have been resolved. And so here, I'm going to very specifically say, after all of my tests, go find that Redis instance and call redis.quit. That will close my connection to my dependency and allow my tests to finish correctly. So we did both unit tests and integration tests. Now, in this case, we chose to put them all together in one Jest test suite. But we can say, what's test? We'll just run Jest. So I'm going to come here to my API. and let's say npm test. This will run both the unit tests and the integration tests against our API. So let's go validate that we're able to mock out various pieces, and also validate that if we hit the real thing, that will actually integrate, actually function as expected. Yeah, my machine is completely overloaded. This should not take 12 seconds. But it does take a little bit to be able to spin up Redis and to get that connection established. So 22 seconds is definitely extreme for this, though. And it looks like all of our tests pass. Excellent. So we did all of our unit tests and integration tests. In this case, we chose to include them in one suite, but now we know our API works as expected. In our build, and we'll come back to this, we could just say npm test, and we'll run all of our tests. Now let's take a look at the app. If we want to do the app, we might want to do API tests to validate that the app's interface behaves the way we expect. So let's take a look at those integration tests. Now this is from here down, but this isn't the way the user interacts with the app. This is only the app's API surface. So I'm going to go grab Axios in the way that I use in my regular application. I'll presume that I've got a base URL running, a web server running on that URL, and I'll just go get the scores. This looks rather familiar. Let's call Axios. We'll go get/API/score, get the response. The result we'll presume is a score, and we'll validate that it looks as expected. And then we'll post the scores, do a similar thing, passing in a particular player. And then we'll also validate that the get before we update it and the post after we update it are only different in X, but not different in O and tie. So this integration test looks a whole lot like the integration test on the backend. Now, in this case, we're doing it as a black box test, a closed box test, as opposed to previously where it was a white box test or an open test, where we kind of understood our internals. Here in this integration test, we just assumed that this server was running. So maybe to be able to kick this up, we have to start our server first. So here in package.json, I'm going to say, well, here's my API tests. Test my, oh, those are the end-to-end tests. Let me test my API. I'll just run jest with this API config that will run just those ones. And before I start this, I want to run start server and test. Start server and test is an npm module that will start up a server. So it will call start API on port 3000, and then it will run these tests. So what is start API? Well, start API will run, where is start API? There it is. It will run npm start, and it will start that API. It will go reach into the other project and launch it. Now, in this case, because we're launching it as a process, we don't have access to its variables. We can't close the Redis connection. And so part of what start server and test will do is it will start this API. And once this test finishes, it will actually go kill that process that it launched. That's a little bit traumatic. We're not closing database connections properly, but that's a good way to do it on the front side. So let's also take a look at end-to-end tests that we might want to run. Now, these end-to-end tests are the way the user will click the buttons. And in this case, I'm using Cypress. So here I've got my cypress.json that says my tests is in this end-to-end folder. So here in my end-to-end folder, I have my tests, and here's my app. Now, I want to go to the home page. Cypress is going to start up my front-end application and get it started. So before each test, I want to go visit that home page. And the cool part about Cypress is I don't need to wait for things to load. By the time cypress.visit finishes, I know my page is loaded, all of the JavaScript is loaded, and the page is ready to go. I like to have a hello world test when I first start a Cypress test to say that my URL should be the URL that I expect. There's times when I've refactored my website and I've moved pages around and I haven't caught up with my Cypress tests. And so this is really great at being able to validate that you're testing what you expect. Even just the difference between HTTP and HTTPS, these tests can be really helpful. Okay, now that I've got the page loaded, let me validate that it works as expected. So let me go grab the title and validate that the title is tic-tac-toe. Another kind of hello world test. It isn't maybe super important here, but it's kind of nice to be able to get a feel for how Cypress works. Next, I want to check for an XWin. So let me click cell 0, cell 1, cell 2, 5, 4, 3, and then 6. So I will test 0, and then 1, and then 2, 5, 4, 3, 6, and that should be an XWin. So click all of those cells, and now let's go validate that number 4 has the win CSS class on it now. That's the red rather than gray. Perfect. So I should check for an XWin. Here's an OWin. We can see that this test is really legible. We're focusing in on the business logic and not the implementation of how to pull that off. Should tie, we'll click through all the things and validate that we tie. And this is a great integration test. It's a great smoke test to validate that our system behaves the way we expect. Now, we also might want to maybe mock out the API. So in this case, this is kind of a end-to-end test, but it's more of a unit test about my application in case the API doesn't exist, or just validating that my API can behave in specific ways. Now, I want to go reach into /API/score, and instead of returning what it actually returns, I want to return this fixture. Here's the results that I want to get from my API. I've now hard-coded that answer. So because that's the score that I get, I can now go look at that score and validate that those scores in that URL exactly match the way I expect it. Now, I could give it an XPath of saying .foo or div inside that or span inside that, but I specifically added a new attribute, a Cypress data-cy attribute, because now if I look at my component, I can see that I've got this data-cy attribute, and I know that that likely means that I have a Cypress test attached to this. If I was to modify this content, I would probably also need to modify a test related to this. So that's a really good clue that, now I have this test that is reaching into that particular element. Now that does mean, am I leaking my development details, my testing details into my production code? I am, but the beauty here is that I now can run my unit tests and my integration tests, my smoke tests in production. Now I can't mock out their dependencies like I did here, but I could validate my key business logic works all the time in production. So let's start at our home page. Let's click on the shopping cart. Let's add a particular item to the shopping cart. Let's get to the checkout page, type in all of our information. Maybe we'll stop just shy of charging the credit card. We don't want our production environment charging a real credit card, but we'll be able to catch all of the different things to validate that a user can purchase and start to check out. Now that can be really helpful to know that our system is working that way in production before our users start to complain and say, hey, I can't add an item to my cart. Yes, let's run these smoke tests in production. So we are leaking our testing concerns into our production code, but I would say that's a great benefit. So we've got this test that will mock out this. We can mock it out a little bit differently. Let's post our score changes. Now, in this case, we didn't mock out the thing. We're just going to go post to that score, giving it this detail, and then wait for X to wait for visit the site again and validate that it is as expected. Now, this win for X is kind of interesting. Here I said win for X. What is win for X? Well, this is, if you've ever used page methods in Selenium, a page object, this is very similar, where I can create my own methods that are able to interact with the page in really interesting ways. So here in my support, I've got some commands, and I have a win for X command. Now it's going to do all of these things. If I do that a whole lot of times, it may not make sense to do that, to duplicate this logic in every place. I've also got a get new game button. The get new game button is really helpful. I just want to say, go get the new game button and click it. That makes my test a whole lot more legible. Now this is TypeScript, and we do need to help TypeScript understand it. We can see that TypeScript's a little bit mad because it hasn't found my command. So I do want to create a TypeScript declaration file. This is a .d.ts that explains what these new methods are. And so now TypeScript can be happy knowing that this new method really is a method the way it expects it. So Cypress does want us to build both a .d.ts and a .ts for these custom methods. One is that TypeScript declaration file showing what these methods do, and the other one is the actual implementation. Ooh, as you go higher in the pyramid, it is normal to see the test duration increase. I agree. Is there a reason why I decided to use Cypress for the end-to-end tests instead of TypeScript? These are actually Cypress tests written in TypeScript. So you can see that I've got TypeScript declarations here. Cypress is the library that allows me to do end-to-end tests because it allows me to interact with the users, the UI in interesting ways. So I can come here and let's switch over to our app. And I can say npm run sci open. I've defined that to be able to launch Cypress. And that will give me the UI piece of how Cypress runs. Now, these Cypress tests are running TypeScript tests, but I can get a feel for how I can click through the buttons and how it interacts. It does take a minute for the Cypress UI to open. Cypress is really cool because it's a browser plugin and an Electron app that allows us to be able to deeply integrate into a browser. Rather than just waiting a bit, we can actually say, hey, wait for the DOM to finish loading. And once it does, continue on straight away. So now I've got my app launched in 8081. And then here comes my Cypress environment. There we go. And here's all the Cypress tests. Oh, I've got an update. I haven't updated to Cypress 10 yet because there's this run all button in Cypress 9 that they've removed in 10, but it looks like I can upgrade to 12. So let's launch this test, and it's going to go start up all of the pieces inside my application. So this is running as if it was a user, and it will start up my app. Here's my app starting to load here. We see the Cypress or the TypeScript build kick off. And so now we're getting great user interactions using Cypress. Cool. So I rigged up these tests here. Let me stop my front end and also stop my back end. I've rigged up these tests to be able to run in sequence to ensure that I start with my fast tests first and progress to my slower tests. So npm test, it will run npm test unit. Here's my test unit where it's just running jest tests given this jest unit config. My jest unit config just says my unit tests are over there. And then once my unit tests succeed, then it will go run test start API end-to-end. Test start API end-to-end will set the environment variable so it knows where to launch my API. Then start server and test will start my API. Here's it starting the API. It's reaching over in this mono repo into that other project to start it. And then it will test API and end-to-end. Here's test API end-to-end, which will say, oh, by the way, set that environment variable. That environment variable is really helpful because here in my end-to-end tests, I say, I don't know what that backend is. Just make sure that that backend is the way I expect, this base URL. So back here in our package JSON, we've set that backend URL. And then let's start our API and end-to-end, test our API and end-to-end. Here's that API and end-to-end. It will run our API tests. That's our integration tests here of our API. And then our end-to-end tests, which are our Cypress tests, those will kick up Cypress. We're using the OpenSSL legacy provider because we're using Webpack 4 with NPM 11. If we upgraded to Webpack 5, then we could get rid of that. And then let's go kick off our Cypress integration test in headless mode. So I want to npm test. That will first run my unit tests. I don't need a web server at all for those. Once my unit tests succeed, it will go kick off my integration tests. Or it'll start my backend server and then run my integration tests. And finally, my Cypress tests. Yeah, the Cypress Studio was removed in Cypress 10, but is back in Cypress 10.7. Oh, excellent. Then it's time for me to update. Great point there. Are you able to generate a Cypress report in your test pipeline? I know SpecFlow can generate such interactive report. I wonder if Cypress offers a similar feature. Good call out. One of the things that I did here in Jest is I very specifically said I would like to add a Jest unit, a JUnit reporter rather, and I want Jest to be able to write my test here in JUnit to this results directory. I do that in my API tests. I also do that in my unit tests. I also do that in my production tests. And so if we now come look here in our source app results, here are all those JUnit results that we can then import into our dashboard of choice. Perhaps we're running GitHub Actions and we just want to grab these in the GitHub Actions dashboard. Or perhaps we want to import these as test results into our Jenkins dashboard. And yes, they're right here. I've chosen to configure those. And so I'll just grab these results files and be able to pull them in. Another interesting asset that Cypress makes available to us is the videos of each run. Now, it's really interesting to be able to launch an integration test, but then it's like, well, what failed? How did it work? What did it do? And so they actually record these videos even when running a headless browser. And then we can use these as build assets as well to say, okay, here's exactly what it did. So if a test failed, we can say, oh, yeah, that's where it was. It clicked on the wrong piece. Not only do we get the build results that we can import into our test result dashboard, but we also get videos to be able to watch when things behave badly. I did that for my API as well, where I wanted to be able to catch those results as well and be able to pull them into my dashboard. So we ran a whole bunch of tests. We ran unit tests, we ran component tests, we ran integration tests, we ran end-to-end tests, we mocked out some dependencies both from NPM imports and for parameters. And how might we then tie this into our DevOps build? Well, here's a DevOps build that I wanted to be able to pull in. I've got this GitHub Actions build in this case. And so I start by setting up Node. I want to use Node 19 in this case. And then what am I going to run? Well, I just run stuff and I go into my API, npm install, npm run build, npm test. My API is the faster of the two, and that's why I chose to run it first. Then I'll go into my app. Let's install with legacy peer depths because Webpack 4. And then let's run build and test. That will test not only my unit tests, but also my integration test reaching into this API to run it, which, by the way, is also why we built it first. And then also run our Cypress test, harvesting all of those results. And in particular, we wanted Redis running here so that we would have that available. So here in GitHub Actions, I said, hey, I would like to spin up Redis first. I would like to map the port here so that by the time my tests are ready to go, I have this fake Redis instance ready to go. So it's going to do that during these tests. And I'll also set these environment variables so that as it's going to pull in the various details, it knows what DB host and port are. So back here in our API, we have this that says, well, I'd like to go set up my connection to Redis, and it's going to get the right answer, pulling in that detail straight from our build. So let's harvest that test report. Let's go grab all of the XML files, all of the JUnit test results, and that will pull that into GitHub Actions. And then we probably also want to deploy our app in an interesting way. But coming back here into our test, let's take a look at our actions. And we see that we've got this one test run. And it's going to do all of the steps that we did. So here's all of the test results. Oh, and it looks like it expired. And here's our test results. So here's the JUnit files for all of these Cypress tests. We saw we got 8 tests in this amount of time, 5 tests in that time. We can take a look at the JUnit results for our API. We can also take a look at the console output for each of those. And so we get a really elegant dashboard showing us all of the test results based on that JUnit test reporter that we pulled in. And ultimately, we saw that, well, all the tests passed, and that's why our build went green. Now, that was really cool to look through all of the different types of tests that were in all of the various places. Any questions on any of the content that we've got so far?
Nothing else on the chat, yeah.
Excellent. So yeah, we dug deep into how to test all of the pieces: unit tests, integration tests, end-to-end tests, mocking in interesting ways. We saw that how we used lots of different libraries to be able to pull off interesting things. Now, we did a bunch of different tests. Unit tests with Jest. We mocked our dependencies with TS Automock. We mocked our imports with TS Mock Imports. We tested our components with test utils. In this case, we used the Vue test utils. We ran our API tests with Axios. And we ran our end-to-end tests with Cypress. Now, all of these, both our source code and our tests, were written in TypeScript, and that allowed us to be able to validate the types as we went as well. We did a DevOps integration with GitHub Actions, and we saw how, because we output our content with JUnit test results, we're able to then import that into GitHub Actions to show us our results. Now, we did a lot of testing today, but we could definitely also go farther. Do we want to do performance tests, static analysis tests, validate that our UI is rendering correctly? We might be able to render other form factors. Maybe we want it to work on a phone or a watch. We could take a look at low vision contrast tests. We could do security scans or fuzz testing. We could do exploratory testing or even manual tests. We could definitely take this a lot farther. But we did see how we could start to leverage our testing pyramid to focus on lots of unit tests, a few integration tests, and just a few end-to-end tests. And as we want to layer in these other tests, we definitely can. Taking a look at our testing pyramid, we saw that as we started moving from unit tests into integration tests, we ended up with real dependencies. For unit tests, we probably faked our dependencies. Taking a look at our testing pyramid and the type of tools that we used, for end-to-end tests, we use Cypress. For integration tests, we use Supertest or Axios. For unit tests, we use Jest. And then we also mocked our things. We used TS Automock to mock parameters and TS Mock Imports to mock our NPM imports. And we can kind of see then how these tests fit into that testing pyramid. Ultimately, though, taking a step back, the purpose of our tests, yeah, we were able to validate our behaviors and boundaries. That was great. We were able to say this piece of logic works in the expected way, and it fits into context in this way, and our end-to-end, our app functions as expected. But another purpose of our tests is to document our code's intent. Remember in our test where our test laid out the grid of squares? It made it really easy for us to then look at our tests and understand how our system behaves. Tests can be a really great form of documentation if you focus on testing for legibility and not just testing to ensure behaviors and boundaries. And finally, risk mitigation. Now, it's important in our sense, in our game, that you can't click on a cell twice, that when the game is over, that it finishes. But maybe it's less important to validate that we've spelled player correctly or validated that it rendered in unusual screens. And so we focused our tests on the behavior of the application and not really on ensuring 100% code coverage. Our goal is risk mitigation. And so we chose the pieces of our business that were important, focused on that, validating that business logic, and maybe left some of the more obscure things that were more difficult to test. We kind of left those aside. Some best practices as we're going here. Ideally, the tests should be simpler than the implementation. We don't want to duplicate our functionality in both test and in source code, because at that point, all we're validating is that, well, we did it. We're not validating that it behaves as expected. So we specifically coded our test to be simpler. We hard-coded specific values, and we validated that we got that result based on our implementation. We also did the arrange, act, assert pattern. This can be a really elegant way for being able to set up the conditions that we need, then execute the content, and then validate that our parameters acted as expected. Sometimes I'll add a fourth section to set up mocks if they get particularly hairy, but that's where I kind of lean on their tests should be simpler. If your implementation, if your setup is getting hairy, we move those into smaller methods so that our test could really be focused on our business logic. We ran our fast tests first. We ran our unit tests first before we ran our integration tests. We ran our integration tests before we ran our end-to-end tests so that we can fail fast and get results quickly. But ultimately, we did run all of our tests to be able to validate that our system is as expected. One of the best practices that we did is we made sure that we closed our database connections. If you've got integration tests in your backend and you've launched connections to external resources and you haven't closed those external resources at the end of all tests, then all of your tests may pass and the test suite may hang. If your tests are running for a really long time after you've gotten all the results, you might want to go check to see if you've closed your database connections. Our goal is to have a 10-minute build. If we've got a build that is, oh, I've got a quacking machine. If you've got a build that is 10 minutes or less, then that's enough time to maybe get up, grab a tea, but you're probably not moving on to the next task yet. If your build takes a half an hour or a day, then it's oftentimes that the developer has moved on to the next task. And if there's an error, it's difficult to get back into context. So you want to balance the thoroughness of your tests with the speediness of your test to kind of maybe hit that 10-minute window. If you can get them in within 10 minutes, the developer is usually still in flow, in context, and is able to jump right back into those tests and solve any concerns. Risk mitigation. The faster the feedback loop is, the better. I completely agree. Towards risk mitigation. Sometimes when you're building a prototype or you're building, just a quick something, it doesn't make sense to write tests. The goal there is to explore the space. And so we're expecting that there's going to be some risk, but the time it takes to build our tests is probably not warranted for a quick prototype. Sometimes it's just important to do it quickly. In our case, we've kind of reached our solution. We're creating a more professional application. And so we built out these tests to be able to mitigate the risk involved in this problem. But ultimately, take a look at the business. Does the business value tests? Is this really going to prevent outages? Is that risk worth it? In which case, yes, we definitely want to lean in and build tests. We started out with a blank screen and we quickly created a test. Getting to one test, getting that to run in your build system, getting the build results to show on the dashboard, that's probably the easiest system of getting started. Get from 0 test to 1 test, and at that point, now you can start to explore it. Testing is fun and easy. We did a lot here today to be able to get testing done, and I would invite you to do the same. Testing is fun. Go do it. The code that we saw is online on GitHub right now. If you want to get to it really easy, head off to robrich.org, click on presentations, and you can get straight to the code and the slides for this presentation online right now. If you're watching this video on demand, hit me up on Twitter at rob_rich or find me on Mastodon, and let's definitely continue the conversation. But for those of us here live at the event, what are your thoughts? What are your questions? What additional tests would you write in this space? What tools have you enjoyed in doing JavaScript or TypeScript testing?
So people, if you have questions, let us know in the chat if you want us to tell it, or if you want to unmute and ask it yourself. In the meantime, well, that was a very ambitious solution for a tic-tac-toe. When you look at it, that's a lot of work over there. And actually, so I have a question, which is more general on the test pyramid. So I have my opinion on it, and I don't necessarily agree with the statement, but I've seen recently more talks about the pyramid being challenged, like where having tons of unit tests is not a good thing anymore, and where people focus is more on, or solely on, end-to-end tests because it's the test that provides more value. What's your point of view about that?
I can see the value in that point of view because I agree end-to-end tests are at a higher level. And so we're kind of documenting the features that users care about. But they're also slower. And so at that point, it's like, well, can I unit test pieces of functionality rather than just functions? Can I kind of maybe take a step up and unit test the public interfaces of my components rather than the actual implementations of my components? At that point, maybe I can reach that goal of really documenting customer value, even with unit tests, rather than having to go more towards a slower system, an end-to-end test system. Ultimately, though, if you're used to writing really low-level unit tests, and then the moment that you refactor your code, you throw them all away, I agree, you'll probably find more durability in end-to-end tests. Cypress tests that click through your interface are probably going to be more durable than testing your implementation with unit tests.
I do agree, and actually the problem I saw on this point of view is the scope of end-to-end tests is too big. When they fail, it's sometimes hard to find out why they failed and what broke. While if you have unit tests, they are more isolated and easier to basically, it's easy with them to tell you what's going on. We have a question from 12 Minico. Thanks for that. Did you already explore solutions such as Code.js that are embedding several test frameworks that you could easily switch by configuration? And if yes, why don't you use present such solutions? Any disadvantages, maybe?
Good question. I haven't explored Concept.js. I have switched from Mocha with Try to Jest in some projects. I have switched from Jasmine to Mocha with Try. And so that might be interesting. Maybe Concept.js makes it easier to do that. At the end of the day, though, I usually kind of embrace the test framework that I've got. And so I don't really have the need to be able to switch frameworks with configuration. That is really intriguing, though. What do you find really effective about Concept.js? Why do you choose to implement it rather than just using one test framework and running with it?
So this is not a question, but we'll say it anyway because it's very interesting. Thank you, Rob. Such an eye-opening presentation. I come from a testing background, automating UI tests, but it was really interesting to see tests in the other areas of the pyramid. That's great. Thanks for saying that.
Excellent. I'm so glad that you enjoyed this presentation. Yeah, I definitely did go overboard testing such a simple app, but it was fun to explore all of the different test types. I'm glad that's the take-home message that you got.
So I don't think we have any more questions. Doesn't look like it. If you have one question, now is the time to say it just before we close it. Anyway, I really want to thank you, Rob, for taking the time to be with us today. And it's not the first talk I see from you, and they're always very interesting. I really encourage you to go to see Rob's blog and website, because he had a tremendous amount of content. That's impressive. I was really surprised the first time that I saw that. So really check it out. And thank you again for being here with us. Lisa, you asked which YouTube channel is for the recording. It's the YouTube channel for the Software Craft Luxembourg. Tina and Arthur shared the link. Thank you, both of us. And what I wanted to say, I don't remember. I know that. Thanks for taking your time to be with us today. And if you want to come back to us, we'll be very happy to have you again. And I hope I will be able to see you for real soon again.
Yeah, that sounds like a lot of fun. I've had a lot of fun in Luxembourg today, and I'd love to join you again.
Yeah, cool. We'll talk about that then.
Sounds great.
Cool. Well, thanks, everyone. Thanks for staying with us, and have a great day, have a great evening, and see you soon.
Sounds great. Thanks, everyone.
Bye-bye.